Hello everyone and welcome to the OpenCL panel at this year's IWOCL and SYCLcon 2022. Thank you for joining us. My name is Simon McIntosh-Smith. I'm going to be the chair for this panel session. Thank you for joining us all over the world. I know we have people joining from the west coast of the US, from across Europe and over into Asia. So you're all very welcome. This is one of the live sessions that we have at IWOCL and SYCLcon this year. These panels are usually really good fun. They're your chance to put some questions to people behind the standard, to people who implement the standard, and to other users of the standard. So I hope you've been thinking up some really great questions to ask our panel, and we'll meet them in just a moment. But before we do, I'd just like to say how we're going to run the panel. So in order to put your questions to the panel members, please use the Zoom Q&A button. Don't use the chat for that. So use the Q&A button. And then we have a moderator who's going to be filtering through those questions. And I'll try and put as many of those as we can to the speakers. So use the Q&A button, not the chat button, to post your questions. If you have any other comments about the chat, for some reason it doesn't work, or any other logistical questions, problems with Zoom, use the Zoom chat for that, and someone hopefully will come on and help you out there. You may have heard we are recording the webinar, so we will be recording this, and we'll post the link for that after we finished, and we'll tell you where that will go. And also we will send out a survey after the panel. We really like to make these sessions work as well as possible, and we're always open to ideas and suggestions. So please do fill in. It's a really short, quick survey, take almost no time to do. Send that back to us after the panel session, and that will really help us in the future. So that's pretty much it. Now, if I can now ask all the panel members to turn their cameras on, including me, so you can see all our lovely faces. We are real people. We're not chat bots or anything like that. We are really here. So as I said, I'm Simon McIntosh-Smith. I'm a professor of high performance computing at the University of Bristol, and I'll be chairing the session. I'm just going to run around the panel and ask each of them to introduce themselves in a few sentences in their own words. So if we start off with Neil, would you like to introduce yourself?
Yeah, thanks, Simon. Hey, everyone. I'm Neil Trevitz. My day job's at NVIDIA, and I'm also the chair of the OpenCL working group. I was looking it up this morning. I've been chair since 2008, and Kernels president.
Thank you, Neil. Balaji, can you go next?
Sure. I'm Balaji Kalidas. I'm the engineering lead for OpenCL at Qualcomm, and I work on OpenCL and machine learning acceleration.
Thank you. We'll carry on clockwise. Alistair, can you introduce yourself next?
Hi, I'm Alistair Murray. I'm at CodePlay, where I oversee our implementations of OpenCL and SYCL, and I'm in the OpenCL working group and tinker in the spec.
Thank you, Alistair. Ben, please say hello.
Hi, everybody. I'm Ben. I work on low-level software for Intel GPUs. I'm active in the OpenCL working group, but also SPIR-V and a little bit of SYCL. And I also maintain the open source OpenCL intercept layer.
Great, thank you, Ben. Mate, can you say hello as well?
Yes, hello. I'm Mate Magyagri, and I'm a performance engineer at StreamHPC. And we work with all sorts of accelerator technologies, HIP, CUDA, SYCL, OpenCL, you name it. And OpenCL is near and dear to our hearts.
Excellent, thank you. I remember StreamHPC being involved in IWOCL and SYCLcon since the very beginning, so it's nice that you're still involved today. And last but not least, Moritz, please introduce yourself.
Hi everyone, I'm Moritz Lehmann. I'm a theoretical physicist at the University of Bayreuth. I'm doing my PhD at the Collaborative Research Center Microplastics, and I'm studying the transport of microplastics across the water-air interface, and I'm doing this with computational fluid dynamics. And for this, I wrote my own software completely from scratch in OpenCL, so I do it with the lattice Boltzmann method and the volume of fluid model.
Wonderful, thank you. And I know you produce some amazing ray tracing pictures with OpenCL on Twitter. So if people haven't seen that yet, go and check it out. They're really cool. Great, thank you everyone. So I can see we've got questions starting to come in. So I'm going to give the audience a couple of minutes just to add a few more questions in the Q&A. And what we'll do is I'll stop sharing my screen. And then you can see us all a little bit better. There we go. You can see all our faces now. And before we go to the first questions from the audience, I've got one. Given this is the 10th year that we've been running this conference, I thought it'd be really interesting to see what the panel thinks OpenCL's really contributed. So if I ask you the question, what have been the biggest contributions from OpenCL over the last 10 years? What would you say? And maybe I should put that to Neil first, and then I'll open it up to anyone else who'd like to offer a contribution from the last 10 years. What's OpenCL really contributed?
Well, I think in the end, OpenCL's major contribution and achievement, it has become pretty well the most widely adopted data parallel programming framework that's used by lots of developers and libraries, applications across the industry, and it's developer friendly, and so it stands in its own right. But I think looking back through the history, it's also played a role in initiating other awesome projects like SPIR-V was originally an OpenCL project, and of course SYCL was originally spun out of OpenCL. So OpenCL is the root of a family tree.
Great, thank you, Neil. Anyone else got anything interesting they'd like to add to what's OpenCL really contributed over the last decade?
I would say one of the really great benefits of OpenCL is that it runs on almost any device, on any GPU from any vendor, and you don't have to specially adapt your code for a new graphics card. It's all handled by the vendors who do the OpenCL runtime, and you write one code and it runs on any hardware, from mobile devices, from mobile phones to the fastest data center GPUs, also CPUs if GPUs don't have enough memory. And this is really great that you only have to write your code once and it runs across such a vast, such a large database of devices.
Great, thank you.
I was going to answer similarly. I think that OpenCL was really ahead of its time with the heterogeneous offload to accelerators. I mean, it's not just CPUs and GPUs, it's now FPGAs, and really any type of device can run OpenCL, and that's been huge. It birthed a lot of different APIs that are now gaining traction, like SYCL in one API.
Yeah, and that was actually one of the first things that attracted me to OpenCL. I saw a demo of it at Supercomputing in 2009. It was actually Ben Bergen running a code as a Los Alamos demo, and he was running one OpenCL application across, I think it was CPUs, it was Intel and AMD CPUs, AMD and NVIDIA GPUs, and some IBM Cell processors, which was what was in Roadrunner. And it was running across all of them at once, when I'd never seen anything like it. And that's what sort of attracted me to OpenCL in the first place. So that was really heterogeneous all the way back in 2009, and that's even more applicable today, isn't it? Thank you. There's actually an interesting sort of follow-on question which has come in from the audience, which is, okay, we've been talking about maybe what's been the big things for OpenCL the last 10 years. What's the next big thing for OpenCL? What's the next big thing for OpenCL? Who'd like to have a go at that?
I think, well, in terms of the ecosystem, there's actually two tracks. There's adding new functionality to the API, and there's lots of good things in the pipeline, and folks here can chip in on that. But I think the other important thing is to make sure that the ecosystem in the larger sense is healthy, and that means ongoing investment in the tooling, the SDK, the documentation, educational materials. It's something, maybe not as sexy as putting in new functions in the API and new language features, but it's critical to make sure that OpenCL continues to thrive. Is we have to, as a working group, really focus on that side of the ecosystem, as well as the pure engineering of the API and the languages.
No, that's a really good point. And those are the parts that are often neglected, aren't they, and what makes these things successful. So
There, one of the features which still needs to be exploited in the ecosystem is layers. Like, it's a fairly new feature of the ICD loader, and it's something Vulkan had for ages, or since the beginning. OpenCL has recently learned how to load layers between the applications and the runtimes. And I think that we still have a lot of interesting layers which the community will write, and Stream is currently engaged in writing layers, but I think we'll see a lot of interesting stuff come out of that in the future.
very cool. Thank you. Any other ideas for that one? What's the next big thing?
I don't know if it's the next big thing, but
Yeah.
in the future, I think there will need to be more work going on and continuing to improve the support for different parallel or more detailed parallel execution models. Like, there is work going on for things like subgroups, and there's vendor extensions for things like joint matrix. But I think hardware's, like, cores within hardware are becoming increasingly connected, and that puts even more strain on the parallel and memory models. So maybe not the next big thing, but I think it's in our future.
Sounds cool. Thank you. I'm going to go on to the first question we had submitted now. But before I do that, for the audience, you might think you're just asking us questions, but no. We would also like to ask you some questions. So you're going to have to pay attention, and we're going to ask you some questions now. It's a great chance for us to get some feedback and some ideas from all of you. So if we can have our first poll question for the audience. And the first poll question, I'll just remind myself what it is about OpenCL optional feature support. And we'd like to ask you which optional OpenCL features you wish were supported more broadly. So this is a great chance for us to ask you what things we should be pushing harder. So hopefully that question is coming up. When you see it, you can make your choice, and we will have a few more questions for you later on, but that's the first one. Great, thank you for your input. Right, we'll come back to questions from the audience now. So the first one we had was actually related to OpenCL and SYCL. And it's SYCL 2020 added unified shared memory, which seems like a much easier to use version of OpenCL's shared virtual memory. When will OpenCL add support for USM? So is there a plan for OpenCL to add support for USM? Anyone who could take that?
So maybe I can start with this, and then other people can chime in too. So we do have a vendor-specific extension that has unified shared memory support in OpenCL. So it's implemented. You could try it out today. I think we support it on pretty much all of our devices. So that'd be a great way to kind of kick the tires and see if you agree with the submitter of the question that it is easier to use. And then if you like it, definitely feed that back into the working group or into other OpenCL vendors and tell us what you like and what you don't. And we can always fix it when we, if and when we standardize the extension.
Right. And so does it really make a difference if people give feedback to you or to the standards body? Does that really affect what happens? I mean, I kind of know, but it's good for you guys to say.
Absolutely, positively, yes.
Yeah.
And we need that feedback. Else we're just designing in an ivory tower, and that is no good for anyone. Life's too short, and we want to actually spend the resources and time doing stuff that's going to move the needle. And USM in particular does keep coming up on close to the top of the list on the feedback that we get. So yeah, encourage everyone to please tell us.
Great, thank you. So whoever asked the question and anyone else, if you're interested in that, sounds like you can try it out on at least the Intel platform, and please give feedback that you want it. It is easier for whatever reason to whichever vendors you work with and to the standards group, and that really does make a difference. So thank you for the question. There's a sort of follow-on question to that, which is how do OpenCL and SYCL fit together? And that's quite an interesting question because it started out one way and they've both evolved, haven't they? So who'd like to tackle how do OpenCL and SYCL fit together? Is that one for Alistair or Neil?
Alistair, probably. is better? Or
Yeah.
Go for it, Alex.
They fit together very nicely. So in CodePlay, we started doing SYCL on top of OpenCL, and we still do SYCL on top of OpenCL. I would say for our compute CVP product, that's our primary backend still. Yes, SYCL has generalized to have more backends, but OpenCL is still an excellent choice for SYCL. And from a programmer's perspective, they just pick the tool that you like the best, really.
And Neil, there's probably a related question, which is how you sort of see them. What's the sort of official relationship between them as they now both evolve?
So I think the important thing is that, as Alistair says, that they should both exist and have their own value to their own developer ecosystems. It's up to OpenCL, even though that's where it started, it's up to OpenCL to earn its right to be a SYCL backend by being an effective platform. We do have discussions in the working group where we're putting in stuff, and it's a plus point on the list of potential candidates if it's going to help SYCL layered implementations. But I also think it's great that SYCL is targeting other backends. One of the interesting challenges that OpenCL has, it's not always available everywhere you want it to be, and if SYCL can have that kind of deployment flexibility by supporting other backend targets, that's a good thing. I'm a big believer in Darwinism rather than diktat. So things should do what they should do in their own right. But I think it's really great that we have a close cooperation between SYCL and OpenCL.
SYCL is pushing hard on new features. So USM has already been come up as a question. There's things like that where SYCL is pushing ahead of features, and I think that can help guide OpenCL as well.
Great, thank you. Just a reminder for the audience, in case you missed the beginning, to ask questions, if you could use the Zoom Q&A, and then the chat, we're just using that if you have any sort of logistical problems with Zoom. So if you need any help with Zoom or something's not working, use chat for that. But any questions you'd like to post to the panel, please put them in the QA on Zoom. Thank you. Next question from the audience. What tooling is missing from the OpenCL ecosystem? And maybe I'll ask Moritz this question first. As you've been using OpenCL in lots of places, is there anything been missing that you really wish that you'd had?
And there's not a lot of things. So OpenCL is already a really good standard, and especially the math functionality, the vectors, the float3 data type, for example, I used it all the time, and the cross product, etc. What's missing for me is floating point atomic addition. There's a workaround for this from the Stream HPC website where you use the integer atomic exchange function to emulate it. However, on NVIDIA hardware, it is supported natively, and you could also do a workaround with PTX inline assembly. However, both variants are a bit of a hack, and it would be much nicer if OpenCL would support it natively.
And what about tools as well? So things like profilers or debuggers or math libraries, anything there that you really missed?
Yeah, over the years, I've sort of built my own tools for profiling and other stuff. For example, in the last year or so, I've written a C++ wrapper for OpenCL to reduce the code overhead to about 1/4 on the C++ side. So no duplicate code for the OpenCL buffers and the C++ arrays for the memory, and I can just use then the wrapper functions to shift memory around from GPU to CPU and vice versa. And it's also very useful to keep track of the data types of buffers and of the buffer length, for example. So you don't need lots of sort of global variables floating around and elongating the code and making it less maintainable. And it's a really nice way to clean up the code, to make it more readable and a lot shorter. And I'm sort of working to rebuild my lattice Boltzmann simulation code on top of this new OpenCL wrapper tool to make the C++ side much shorter. And for profiling and for debugging, I'm sort of using the old school tools. So for profiling, I use the Chrono library on C++, which can measure times down to the nanosecond. So I can measure the kernel execution times. If there's some bug in the OpenCL code, I can print the build log in the console. Actually, my C++ wrapper does it automatically for me now. And of course, there's the old school trick. If you have like hundreds or even thousands of lines of code and there's somewhere an error in it that makes the code keep crashing, then you comment out the second half of the code and run it. It doesn't produce like the correct results, but the test is just to see if it runs all the way through or if it crashes. And if it crashes, you know that the error must be in the first half of the code, and then you can comment out more parts of the code or less parts and repeat this sort of bisection technique until you arrive at the one single line that causes the error. It's a really powerful tool, and it can be used in any programming language, so not just OpenCL.
Cool, thank you. Mate, how about you? Are there any tools that you've missed that you wish you had? Profilers, debuggers, other things?
First, I just wanted to respond to the floating atomics. Like recently, there's a vendor-neutral extension, CLX float atomics. So if somebody's interested in using that, then give it a try. And from that point on, it's just
one person by the looks of it, yeah.
It's just letting your vendors know that, hey, I want you to support this. So when it comes to extensions, then yes, users have to bang the vendor's door to make them implement it.
Another thing that I think is interesting for a lot of people, so not really for me, because my lattice Boltzmann stuff is in the memory limit, so I can do on the compute side whatever I want, and it still doesn't run slower or faster because memory bandwidth is the limit. However, many applications are in the compute limit, and especially for stuff like machine learning, where you want to do a lot of matrix multiplication, you want to use the tensor cores on NVIDIA hardware. And currently in OpenCL, the only way to do it is to use inline PTX assembly, which is still a workaround. And it would be really nice if OpenCL could support the tensor cores and dedicated hardware on different vendor GPUs.
Good point. Thank you. We've got loads of questions coming out, which is great. So I'll move us on. I will just say the Kernels OpenCL website has a really good list of resources on tools. So if anyone in the audience isn't aware of what tools do exist, do go and check out the OpenCL Kernels website, and there's lots of things you'll find there. Good. Might be a quick question for somebody. What's the best tool to debug an application on AMD and Windows environment? Does anyone know? Debugging, I guess debug an OpenCL application on AMD and Windows. Does anyone offer a suggestion?
I don't think we have anyone on the panel from AMD, but because my daily driver is AMD based hardware and I'm running on Windows. Somebody also asked in the context of CodeXL if this is the same question. And as far as I know, CodeXL has been discontinued by AMD. And now there are the Radeon profilers. So there's the graphics profiler and analyzer tools, but they do not speak OpenCL yet. So currently for debugging on Windows, since CodeXL was the tool for that, and the rest isn't compatible with it yet, printf debugging is the best tool for that, and the tools which Moritz has mentioned. So printf is still there. I still use it often. So
still like the #1 debug approach all around the world, isn't it? Really, printf. I know it's insane, but people who like debuggers must.
I'm a little biased. I won't claim it's the best tool to debug an application on AMD and Windows, but the OpenCL intercept layer should work on AMD. It definitely works on Windows. We use that all the time to debug at least some classes of problems, and it can do profiling too. So if you haven't taken a look at that, I certainly recommend taking a look.
Thank
So
you, Ben. Could
in
you drop
some
a
sense
link to that in the chat?
If I can figure out how to send it to everybody, I will. Yeah.
Yeah, cool. Sorry, Mate, go ahead.
To circle back to what tooling is missing, the vendor neutral tooling still has rooms to grow. And recently there was a survey that has been published, and one of the top requests is profiling counters. So to be able to read profile counters via an extension, and that would allow to write tooling which is vendor neutral and get at least the profiling counters from the device out.
Yeah, in general, I think there is an opportunity, and this was mentioned before, that OpenCL should invest more in its layers. Taking a lesson from Vulkan, the Vulkan layering tooling is pretty awesome, and we have a real opportunity to invest, and we are investing. We've actually we're putting money into developing those layers right now.
Thank you. This might be a good opportunity to move on to our second poll question for the audience. So there should be a new one. Thank you for your answers to the first one, but the next question is actually about OpenCL competition and what you think the main competition to OpenCL is. We've asked you this at previous panels, and it's just interesting to see how it evolves over time. So hopefully that question will pop up for you soon. But we'll move on to some other questions from the audience now. Let's see. So there's another one, which is, do you have a plan to develop something to move OpenCL kernels on SYCL and make them easier? So OpenCL kernels in SYCL, I guess that's sort of interoperability. I don't know if Alistair, that's one you could handle.
I hope I'm not wrong in saying this, but is that not already in SYCL? Can you not already use OpenCL interop to run an OpenCL kernel via SYCL?
So it might already be there. It's not something I've tried. So,
it is.
Yeah, that is correct.
It is.
So check it out.
That was one of the first ways to use libraries that were initially missing from SYCL. So like the FFT libraries, for example. Right. So one can write compute kernels in SYCL as they would, and then just in between two kernels launch a CLFFT, and it will work just fine. So
that might be a really easy one if it's already there. That'd be great. So maybe go check that out and see if you can find it. And it's what's the feature name? Is it interop?
It's different. Depends on SYCL 1.2.1 or if SYCL 2020. But in SYCL 1.2.1, one can always get the underlying handle from a SYCL queue, and then what they get is the handle to the OpenCL queue, and they can do whatever they want with it.
Right. And it's called something different in SYCL 2020?
In SYCL 2020, you'll go via the OpenCL backend. So of course that will only work on implementations that are based on top of OpenCL.
Yeah, sure. All right, great.
There's also a one API extension that adds support for kind of online compilation generically. So in that one, you'd pass an OpenCL kind of kernel string like you do with your create program from source. And that should allow creating a program from an OpenCL string.
Thank you. While we're talking about SYCL, we'll do a quick SYCL question. Actually, somebody's saying this is really a question for Qualcomm. So Balaji, this one's for you about Qualcomm. Is there a planned SYCL support for Qualcomm SoCs? As now it's declared that OpenCL is supported, but no explicit SYCL support. So are you looking at SYCL for Qualcomm SoCs?
Sure. So it's something that we're continuing to look at actively. So we are tracking SYCL, and we are constantly evaluating if it makes sense for us to support it. I guess one of the thoughts we had is that in the mobile space and embedded, perhaps OpenCL would be attractive, since latency and fine grain sort of dispatch control are more important there. One thing we'd certainly be interested in learning is, the motivation for wanting to use SYCL as opposed to OpenCL. So we really are interested in learning what are the types of problems you expect to solve with SYCL as opposed to OpenCL. Is it the convenience of single source, or there's some other benefits that SYCL brings? So that certainly would help us, make our decision to invest.
Great, thank you. I guess if somebody's really interested in this and your SOCs, maybe get in touch and they can hopefully give you some useful input.
Yes, we'd definitely love to hear from whoever's interested in having SYCL on our SOCs.
Great. And there is the Slack workspace that's been set up for IWOCL and SYCLcon again this year, and we'll all be keeping an eye on that. So that's a good way of keeping a conversation going after the live panel. Great, thank you for the great question. So here's another one. Does the official OpenCL SDK aim to collect all vendor-specific extensions? Oh, it's just moved as well. Previously, I had to copy declarations from the SDKs of various vendors to get up-to-date defines for all vendor-specific extensions. What's the plan for vendor-specific extensions and how to handle all of those in the future? Who can comment on that?
I think that depends on mostly where someone gets their headers from. So if someone like the headers which are found and the loader on Kernels.org, and that's the one the SDK refers to. So they are just Git submodules to the SDK. And if somebody is using recent enough headers on their platform, like that is the canonical place of the headers, and the vendor SDKs shouldn't deviate from that. So that just means that if somebody needs to update their headers, that means that if it's a Linux repository, then the Linux repo has outdated headers. But the SDK does have all the defines, or should have all the defines for all the vendor extensions. So the short answer is yes, that it should cover all the vendor extensions. But if somebody has run into an issue, that must be just outdated headers from wherever they acquired them.
Mm-hmm. So in the SDK is hopefully one good solution to this, to have all of them.
Yes, although Ben wants to say something.
I was just going to say that the SDK is collecting the headers from there's a specific GitHub repo for OpenCL headers, and it's a GitHub repo. So if there's something that's missing, add a pull request and we can add it, because that should be the one kind of source of truth for OpenCL headers. And if something's missing, we should add it.
And Neil, were you going to say something else, or did Ben just?
I was just going to say, just in general, we have done a spring refresh on the SDK. So for deployment and gathering stuff like the right headers. Now, if you haven't checked out the SDK on the Kernels site for a while, go and check it out. And Mate has done a lot of that work. So
I'm the person to blame if there's any mistakes done there.
I was thinking more of praise rather than blame.
And Jeff's been doing brilliantly at posting in links to the chat. So Jeff, I don't know if you can find the link to the SDK and add that one at some point so people can get straight there in the chat. That'd be awesome. Great, thank you. Let's see, where are we up to in the questions coming in? Here's a sort of related one. How does OpenCL see their relationship with the backend technologies such as OFI and OPA? At what point should the language push requirements on the vendors versus the other way around? So OpenCL's relationship with the backend technologies. Who'd like to comment on that? Or shall I pick a volunteer? Do you want to start off, Neil, and then we'll see if we can get someone else to add to that?
I have no idea.
Oh, cool. I don't think we've ever asked you a question you had no idea about before. That's a first. In 10 years. Anyone else able to chip in on that?
Then I'll ask the question, what is OFI and OPA?
Oh,
that's the reason why I can't answer. Like, I don't know.
Okay, I don't know.
are.
I thought you'd know, but okay. Whoever's asked, Joshua, you're going to have to tell us maybe in the chat what's OFI and OPA. and then we'll come back to you. So tell us what OFI and OPA are, and we'll come back to you. I'll move on to the next question while we're waiting for that. Robert asks, what's currently going on to bring Vulkan Compute and OpenCL from the supported feature set closer together? So that's sort of shaders versus compute with SPIR-V. So what's sort of happening between Vulkan and OpenCL? Can I put that one to Neil? I'll put one to you. Hopefully you can, I won't trip you up.
Yeah, well, I can say there's a lot of discussion. And this is a very, it's a very interesting ongoing discussion that's been ongoing for a while. The big picture is, I think it's accurate to say that Vulkan Compute and OpenCL are still trying to figure out how they're going to coexist. We are discovering over time that OpenCL has a lot of good attributes that a lot of people love, and those attributes are different attributes to what you get if you use Vulkan Compute, which is also awesome. But it's not a slam dunk saying, oh, obviously we don't need this one because this one has everything that everyone needs. I think both are going to continue to obviously exist and evolve independently, but it is very interesting how they interrelate and potentially layer over each other. Because one of the market dynamics, which of course is always crucial, is deployment. Can I get my OpenCL applications everywhere I need to? And in many cases, there are native Vulkan drivers and not OpenCL drivers, and sometimes vice versa. So as we've talked in previous years, layering OpenCL over APIs such as Vulkan is going to be important. The CLSPV project from Google is key, and Google continues to invest in that. So if we can close the gaps, we should. I think it's going to be good for everyone. And actually, I just came from a call this morning at the Vulkan working group. They're talking exactly that, and it's not trivial because there are differences in the memory models and the execution models, but I think both groups are motivated to try to close the gaps as much as we can, as quickly as we can.
I think one of the biggest things is that we're trying very hard not to drive the two further apart. So when we get new features like the integer dot product would be an example, there a lot of them are going into SPIR-V, and when they go into SPIR-V, you can support them in either Vulkan or in OpenCL. So we shouldn't be seeing a lot of new features that are applicable to both and that are added in one API or the other. Kind of behind the scenes, there are some activities, again, largely driven by the SPIR-V working group to bring them closer together, and they're happening. It's a little bit slowly, and it's a little bit kind of inside baseball for compiler people, like, can you cast pointers from one type to another? But slowly but surely they are, I would say, they are approaching convergence, but they're still pretty far apart, and it's not going to happen overnight.
Thank you. And we actually have an addition to the panel. Kevin Petit has joined us. Thanks for joining us, Kevin. And he might be being volunteered to see if he's got a comment on this as well because of CLVK. So worth saying something about that here, Kevin?
Thank you, and sorry for the technical difficulties. Took me a while to be able to join. I would say that's been a good learning experience, and that's enabled to me and others to discover maybe some of the differences between Vulkan Compute and OpenCL faster than otherwise we would have by just reading the specs, because it's not always obvious to find the little gaps, and there's no replacement for running the CTS directly on top of a layered implementation to find those problems.
Great, thank you, and thanks for battling through the technical challenges and being able to get here. Just with one eye on the time, we've got a third. We're going to have 4 questions in total for the audience, so I think it's time for our third poll question, which hopefully will come up for you soon. This one's to do with OpenCL versions. And the question will be, what version of OpenCL are you currently using? This is a good one to kind of track historically. So we got the data from last year, for example. So what version of OpenCL are you currently using? That poll question should come up soon. And it's surprising, I think last time we asked, most people were still using 1.2, which is from how many years ago? Can anyone remember? When did 1.2 come out? 10 years ago, possibly. I don't know. Quite a while ago.
It's about that, yeah.
Yeah. So we'll be really interested to find out your answers to this one as well. So do click on the poll. In the meantime, Joshua's come back to us and he's explained what OFI and OPA are. And they are actually like InfiniBand and OmniPath. So the actual sort of interconnect technologies that we often have in supercomputers. So the question was, how does OpenCL see their relationship with back-end, I guess, communication technologies such as OFI and OPA, so things like InfiniBand? At what point should the language push requirements on the vendors versus the other way around? So we know it's to do with communication over interconnects now.
Very interesting question. The fact that no one in the OpenCL working group even recognized the acronyms shows that perhaps we should be more aware. I can see how maybe the interconnect should drive functionality. So yeah, actually, thank you for the embarrassment of not knowing what those acronyms are. We should go and do more research. But I certainly don't have an answer right now. But I think the working group hasn't discussed that perspective yet, but maybe we should.
We've had some projects in the past where people have done sort of remote OpenCL, haven't they, where you can have a host in one server driving devices in other servers going over InfiniBand and OmniPath, but they've generally been sort of third-party projects, haven't they?
Right.
Interesting one. Thank you for raising it. That's a good head scratcher. That might be a good one to keep following up in the Slack afterwards on that one.
Yeah.
Good. Let's see, where have we got to? Someone's asked, I've experimented with interoperability between OpenCL and OpenGL. Is someone else using this feature to process data and provide it to direct visualizations on textures? So is anyone, and this is something, when we used to run tutorials, we used to talk about OpenCL, OpenGL interop, but we haven't really talked about it for a while. Is this something, anyone aware of this being actively used in this kind of way?
Yeah, I can talk to it. Yes, it's actually extremely popular. There's lots of applications on our SoCs that are using OpenCL and OpenGL interop. And so that's pretty well defined. I think the spec works really well for that. And if you use CL, KHR, EGL sync, and forget what the other one is, I think the EGL fence sync events, you'll get extremely fast synchronization as well. So yeah, I think it's pretty popular. It's very useful, and it's sort of a well-defined, well-used path.
Yes, I wanted to mention, if somebody has used GIMP in the past, which is an open source Photoshop alternative, then that uses this too. GIMP uses Gaggle as its backend, and that's a library which is doing all the image manipulation, and GIMP as the program is only just rendering the UI. And those two talk together using this OpenCL interop. So GIMP gets the frame buffer as a window, creates an interop context, and just passes it on to the backend. And the backend takes care of all the image manipulation. And then GIMP, just when the image is done, puts it on the screen. So if anybody has used GIMP in the past, then they've used this feature under the hood.
Wow, I didn't know that. Very cool.
Two other quick plugs. There's a couple of new OpenCL SDK samples that use CLGL sharing. So if it reproduces with those SDK samples, that's a great way to pass it on to the vendor where you're having problems. And also we defined a couple of new extensions recently. They're provisional extensions, so there's still a chance to provide feedback that allow interop between Vulkan and OpenCL, and also a bunch of other APIs. It works on kind of underlying OS specific handles. So it should work for DX12 also, and allow for even more types of interop.
Very cool. I think we had a few slides on this in the hands-on OpenCL online tutorial as well that talked about how to do CLGL interop. Excellent, there you go. So the good news is lots of people are doing this apparently, and it's really popular, even in GIMP, so that's awesome. Cool, we've got a really interesting question next, which is the Kernels group has many frameworks capable to work in safety critical areas, like automotive and aerospace, such as Vulkan SC, SYCL SC in progress, OpenCL SC. What about usage of OpenCL in safety critical areas? Any thoughts about that?
That's a really interesting question that I'm interested in too. So, yeah, so Kernels has a 20-year history in doing safety critical APIs. OpenCL SC 1.0 was 20 years ago, basically, and now we have Vulkan SC, which was just recently announced earlier this year. And as the questioner rightly points out, there's now a SYCL SC exploratory group, and basically it always those groups are figuring out how to streamline the API and make it more robust and deterministic. Things like taking memory allocation out of the loop, out of the runtime loop, and trying to pre-configure stuff and pre-compile stuff. So there's less surface area and more determinism. It is a very interesting question whether OpenCL should do an OpenCL SC. We've just established a liaison with AutoSAR, which is a large group primarily in Europe using building platforms and software frameworks for the automotive industry, which is one of the main, probably the biggest market for safety critical APIs right now. And they have a strong interest in doing acceleration offload, and they're interested both in SYCL and OpenCL. I'm very interested. It's just started. It's very new. We're about to kind of have the first meetings. I'm very interested to see whether there is a market demand for OpenCL SC. But it is worth saying that just because there isn't an OpenCL with an SC at the end doesn't mean you can't use OpenCL in safety critical. It just means there might be more that we can do in the API to make system level certification easier, but it's certainly not impossible. So people can certainly use OpenCL today, but is there more we can do to streamline the process?
So that was a great question from Andrew. Andrew, it sounds like there might be interest here, so it might be worth you getting in touch. And if you've got some requirements or some ideas, or there's a market you're aware of here, it's definitely worth getting in touch with Neil and the others, maybe via Slack or something like that afterwards. Thank you for the question. Here's one that I can see he's already grabbed. He wants to answer this next one live. Is any work done towards CUDA graphs-like functionality in OpenCL? So Kevin, you want to comment on this?
Yes, clicked very eagerly. I think it's pretty much there today with the release of the command buffer extensions. There's now the ability to capture task graphs, and yep.
Okay.
The group is busy working on extending the functionality further, and if there's something that people can spot that is supported by CUDA graphs and that we can't easily do with OpenCL with the new proposed extensions, then please flag it. That's feedback the group would love to hear.
Cool. So hopefully that's good news for the person who asked the question, Yanis. So if it sounds like there's some new features that are worth trying, and if it doesn't quite do everything you need, definitely let people know, and hopefully we can close those gaps. Great.
Let me just mention that just recently on the OpenCL docs, somebody opened an issue which captures their insights as to how this extension should work, or like what they think of it, what may be the shortcomings. So feel free to chime in or open another issue if you have other thoughts.
Yeah, I'm not sure if there's any publicly available implementations yet, but the extension specification it's in the extension spec and it is provisional right now, so we absolutely can still take on feedback. We would love some feedback, or more feedback.
Awesome. And I know when everyone says this, you genuinely mean it. We're kind of desperate for feedback and comments from anyone, so please do let us know. Great. With one eye on the time, because amazingly we only have 9 minutes left already. Don't these things fly? We've answered more than 13 questions, I think, but there's still 12 open. We might not get to all of them, I don't think, but we'll try and do a few more. Given we haven't got long left, we'll move on to our last poll question. So 4 of 4, which is about OpenCL targets, and we're going to ask you all, what CPU and operating systems do you currently target with OpenCL? So we'd love to know about that too. So please do click on the poll when you have a minute. And there's actually then a related question which we'll put to the panel, and it's tagged as for Neil. So Neil, get ready. And it's, would you say OpenCL 3.0 has been a success in terms of adoption compared to OpenCL 2.x?
Yes. A big
Next.
No, big success. I mean, no, this is something we look at quite closely because adoption is our primary measure of success. So OpenCL 3 has had significantly more adoption from the hardware community than OpenCL 2.x. As we talked in previous IWOCLs, in some regard, OpenCL 2.x tried to pack too much in and made it non-optional. It made it almost impossible for people to deploy, and that was the whole point of OpenCL 3, to unblock that. So, and it's worked, because so now we have 10 processor vendors have adopted, and most of them are now shipping conformant OpenCL 3. So yes, an unqualified success. I think there's obviously more to do, but it's worked. The unblocking the logjam worked.
Excellent, thank you, and thank you for that question too. Let's see. Just skimming down the rest of the questions to see which ones we haven't answered yet. So there's one, in the SYCL ecosystem, we have to make a translation between SPEAR and SPEAR-V. Why bother with that? Why is that necessary? Anyone comments? It's slightly more of a SYCL question, but we'll take it. Does anyone know about that?
No, I think it's an interesting question. So there's no requirement to make a translation to SPEAR or to SPEAR-V to compile SYCL, and certainly you don't need to go through both. But it is a helpful way of kind of doing the handoff between the SYCL compiler and an underlying runtime. So I guess most of these tool chains go from some form of LLVMIR, and that looks a lot like the older SPEAR, and then they would translate to SPEAR-V and then pass that on to use that as the interchange to the runtime. So I think if you squint your eyes, you can kind of see like how that question works, but there's no requirement to do that. There's no requirement to go to SPEAR. There's no requirement to go to SPEAR-V. If there's some other way of compiling that you choose to and that your runtime supports, a SYCL implementation is free to do that.
Great, thank you, Ben. There's another question here. Are there methods to protect kernel code from sniffing during compilation time? I mean the conversion between code source and binary. And this is sort of a bit SPEAR-V related as well, isn't it? How have people protected their kernel code from being observed? Any good techniques people have come across?
SPEAR-V is probably the most obvious answer.
In binary?
Maybe, yeah, you can maybe obfuscate OpenCL SC as well. I don't know if anyone actually ever has. Yeah,
that was sort of the old method when we had nothing else, wasn't it? But now you can have a SPEAR-V binary. That's like any other binary. You can still reverse engineer binaries, right? You can look at the assembly code, but at least there's a bit more effort to do. But I guess SPEAR-V gives you that sort of, it's like a binary at that point.
Or even go one step farther and just fully ahead of time compile to ISA. Right. You're trading off portability for obfuscation, but that's another option.
Yeah. Yeah, and do you know if either of those methods is widely used in the real world? I know they're all possible, but what do people actually do? Or do they not really care and you just have your kernels as source code?
In general, we do find particularly the higher end professional apps that a lot of investment goes into their kernels. This is a thing.
Yeah.
So, yeah.
So I'd actually, be interested in hearing more from the attendee who asked that question. Are you looking for an extension that would accept an encrypted source? Basically, are you looking for some sort of a extension that would compile encrypted source so it's secure, I guess, until it hits the compiler?
So I guess that's a question back to Fabio. So let us know if you can what you're thinking there, whether the SPIR-V binary is not enough if you need anything more than that. We're interested. Let us know. Good. Right, we're into our last couple of minutes. Let's see, is there a quick one? Is there a quick one we can do? So there's one. Is there any interest at Kernels to adopt HIP or something similar that can be a high-level alternative to CUDA? SYCL is much higher level, while OpenCL is lower level than CUDA, which is, in my opinion, a reason for the wider adoption of CUDA. So what's the feeling of something like HIP, which is the AMD thing, Rishi, isn't it? Anything in that might be interesting to Kernels or might inform SYCL or OpenCL directions? Who can comment on that?
It's an interesting question. Yeah, go ahead.
I would maybe contradict the question a little bit and say that SYCL is a good alternative to CUDA if you want to target a range of hardware.
And also saying like OpenCL is a low-level API, but if one compares it to Vulkan, Metal, or DirectX 12, then they will start to appreciate the high-levelness of OpenCL. So there's one great deal of details exposed by these explicit low-level APIs. But I too wouldn't count on Kernels adopting HIP, at least as these three words imply, anytime soon.
Yes, I think maybe the last thing we need is yet another.
Yes, so
another one.
Yeah. I just wanted to add, there's a tool in the One API toolkit that's the Data Parallel C++ compatibility tool that will actually try to translate source to source a CUDA program into SYCL code. So I think that supports Alistair's kind of assertion that they're on a more similar level than it may initially appear.
So yeah, I guess to add to that, we'd certainly be interested in understanding a little bit more about what's missing from SYCL that HIP provides. In the sense, is there a specific technical reason why HIP feels like a better alternative to CUDA than SYCL?
Very good. And Paul's just commented in the chat. SYCL can already get to AMD GPUs via HipSYCL. Yeah, and there'll be several talks about HipSYCL at IWOCL and SYCLcon this year, so go and check out those HipSYCL related talks. Excellent. Well, unbelievably, it's already the end of the hour. I mean, it goes so fast, doesn't it? First of all, thank you to all of the panelists. It can be a bit scary coming up and you don't know what questions you're going to get, but thank you very much. You all did absolutely brilliantly. Thanks for joining. The virtual round of applause from the audience, I'm sure. Thank you to the audience for coming. I know everyone's very busy, but hopefully this was interesting and useful. Thank you for asking the poll questions. The recording will go online and we'll post a link somewhere obvious that you should all be able to find soon. And please do continue the conversation. So we always like to hear from you. The ideas and comments and suggestions and feedback are really important. Please do get in touch. You can use Slack, you can use the Kernels OpenCL forums. There are lots of ways to get in touch, and we do really want to hear from you, and your ideas and suggestions really do make a difference. So please do get in touch. There's another live panel tomorrow. That one's on SYCL, and there's another live session later today, isn't there, Neil? It's the AI, the ML one is.
Yes.
There's an hour gap, and then there's that one.
That's right, using OpenCL for machine learning. So yeah, see you there.
OpenCL for machine learning. Very good. So if you'd like more of this and to be able to ask more questions, please go along to either of those. With that, we'll wrap it up. Thank you very much again for coming this year. Hopefully we'll be doing this again next year, but in person. We'll try to make it hybrid, so if you can't come along in person, hopefully you can still join in, but hopefully we'll all get together in the real world this time next year. With that, we'll wrap it up. So thank you very much, everyone. Take care, stay safe, and hopefully see you in person next year. Thank you.
Great. Thank you, Simon.
Thank you. Bye.